Good day, welcome. I am Kurt Russell Cisaet.
I'm Princess Base.
I am Jessica Feo Beltran.
And I'm Lovely Inario. And
And
we
we
are
are
your
your
presenters
presenters
for
Presenters
for
for
today.
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 Our research proposal is titled Design and Fabrication of Lenz-type Vertical Axis Wind Turbine in Bagasbas Beach with IoT Electrical Monitoring System. First, let's break down the title. In this proposal, we aim to design and fabricate a vertical axis wind turbine, specifically a Lenz-type one. We chose this type because it is more suitable in locations where the wind direction is ever changing, just like in residential urban areas. In the preliminary stage of our brainstorming process, we plan to install these turbines to household areas, for they will greatly benefit from it in occurrence of frequent power interruption, which is timely and relevant to our province, the Camarines Norte. But in the progress of our brainstorming, we acknowledge that we need a different wind resource assessment study on our chosen residential area for this study to be appropriate and successful. Thankfully, on Barangay Bagasbas, a wind resource assessment study has been conducted, and that is where we plan to install our vertical axis wind turbine. We plan to incorporate Internet of Things in this study because this is the burning thing in the market right now. IoT is incorporated in consumer products from smart TV to smart refrigerator. We saw a potential that IoT will be beneficial in electrical monitoring system of wind turbines. This presentation includes the introduction, objectives, significance of the study, as well as the scope and the limitation. Without further ado, let's start. Among these resources, the wind has proved to be a cheaper alternative energy resource, and hence extensive research efforts have been put to improve the technology of electricity generation through the wind. The world has enormous potential for wind energy that can be utilized for electricity generation. In the first figure, this shows the wind velocities at various locations around the world. The darker shades represent the higher wind mean speed, while the lighter shades represent the slower wind mean speed. On the second figure, this shows the installed wind generation capacity in the world. There are different types of vertical axis wind turbines, and the Darius type is the most popular. It is possible to find different applications for Darius type wind turbines. However, a lot of disadvantages are seen for making it available at a large size. Also, its efficiency is around 30% and there are major difficulties in protecting the Darius turbine from extreme wind conditions and in making it self-start. A Savonius type wind turbine is another possibility. Even though they have low efficiency, they are often used because it's low cost and high durability. Due to the high torque on the rotating shaft, one of the applications is water pumping, according to Nishioka and Almeida on their study last 2018. Based on Darius and Savonius type wind turbine, Dr. Edward Lenz proposed a different kind of mechanical device, combining aerodynamic lift force and drag actions in the rotor airfoils or turbine blades, according to Sivamani et al. On their study last 2017. Since the model consists of a minimal convex surface oriented in the direction of motion of the blades, experience the least amount of backward torque as possible due to the presence of a convex surface, according to Deori et al. On their study last 2015. This shows a sample system of an internet cloud-based system. On our seventh figure, this shows a sample block diagram of data collection system from a wind turbine. In our figure 8, Internet of Things based wind power generator and monitoring system. In this research proposal, an online electrical monitoring system for a Lenz-type vertical axis wind turbine using an online digital dashboard is proposed for an energy generator. The measured data is recorded and stored automatically through a cloud-based system. The performance of the wind turbine is monitored through an online dashboard from a website. In this slide, this shows a sample dashboard on an IoT electrical monitoring system. On our figure number 10, this shows a creative rendition of what it may look like on the proposed location.
All throughout this research, we aim for the following objectives. Our general objective is to design and fabricate Lenz-type vertical axis wind turbine with IoT electrical monitoring system. Our specific objectives are: number 1, to create an eco-friendly power generation source that can attract eco-minded students, teachers, and supporters. Number 2, to monitor and measure the set parameters using the IoT electrical monitoring system. And lastly, to use the technology as a foundation for future researches regarding renewable energy.
This study has a redound benefits to the society. This study will benefit the environment, for vertical axis wind turbines do not release chemical emissions that can pollute the water or air, and it is quieter to operate. Unlike coal, natural gas, or oil, generating electricity from wind doesn't result in greenhouse gas emissions. Wind turbines don't require burning any fossil fuels to operate and may also reduce the amount of electricity generation from it, which results in lower total air pollution and carbon dioxide emissions. This study will benefit especially the province of Camarines Norte, for it will generally help to secure and strengthen the presence of renewable energy systems in the province, to achieve lesser carbon footprints, and to pave way for large-scale renewable energy systems in the future. This will also be beneficial to the residents, for it will encourage them to implement it in their homes and help them to provide green electricity to reduce their dependence on the grid and fossil fuels. Also, this study will raise public awareness about renewable energy that is a part of a circular economy. It will be attractive to eco-minded students, and it will inspire them to do more inventions and innovations to care for the environment, through creating new designs that will surely be a big help to the society as a whole, and to the future researchers, for this will serve as a reference for them to gain knowledge in creating new ideas and for further improvement of the study with relation to this topic.
For the scope and the limitation of the study, this presents the design and analysis activities involved in the fabrication of a Lenz-type vertical axis wind turbine system, where wind energy is used to power a generator to produce an electricity. The study also includes the installation of this wind turbine with an IoT electrical monitoring system on the seawall in Bagasbas Beach in Barangay Bagasbas, Daet, Camarines Norte. The monitoring system measures the wind speed, the amount of power generated, as well as the magnitude of instantaneous voltage. It can all be monitored and tracked, and the recorded data can be accessed anytime and in any location through a website. Other areas will be excluded in the study and will focus only on Bagasbas Beach. Simulation of the said system will be on the future researches.